Here we can derive another equation by using equation number 5 to form another linear equation. Like here, as we know, the equation number 5 is actually log of a over a minus x is equal to k over 2.303 into t. T actually it is the time of reaction proceeding. And by using the principles of logarithm, we may write this equation as log of a minus log of a minus x is equal to k over 2.303 multiplied by t. So by rearranging this equation and replacing the position of left hand side log of a toward the right hand side of this equation, we may write like this: minus log of a minus x is equal to k over 2.303 multiplied by t and negative log of a. So this equation may be multiplied with negative sign, and we will have another form of this equation like that of log of a minus x is equal to minus k over 2.303 into t plus log of a. This is another equation of straight line, and we can represent this equation on our graph like that of plus y is our log of a minus x at y-axis, and t is our x coordinate along x-axis, where slope will be minus k over 2.303, that is our minus m value. And we can find this value by both the method, by measuring the tan theta, and also by drawing a right angle triangle. And b is the intercept of our graph, means to say this linear equation having intercept form. So by drawing this equation on both the coordinates, like at x-axis we have time, at y-axis we have log of a minus x, and by drawing a straight line on these coordinates, we have such type of line where the intercept is the log of a in positive form, and by measuring the angle theta by drawing a parallel line to that of x-axis, we may find the theta angle, which definitely is greater than 90 degree, and its value will be negative, that is actually minus k over 2.303. and by drawing a right angle triangle at any point at any interval of the reaction proceeding, we may find the value of slope that will be equal to perpendicular over base, which will be equal to minus k over 2.303. So by using these values, we can find the value of k, which is rate constant. So this equation is also helpful in order to find the value of rate constant for first order. In this slide, we will have another derivation of linear equation by using equation 4. As we know, the equation number 4 is actually log natural a over a minus x is equal to kt, and by taking its antilog, we may convert this equation like a over a minus x is equal to e raised to power kt. As by anti-logging the left hand side, the log natural value will be nullified or deleted, because we are taking the anti-log of log natural. But in right hand side, e is the natural log's base, and kt is shifted as an exponent of e. E is the natural log base value. If we don't have value of log natural on right hand side, by taking its anti-log, we may shift the value as exponent of the base of that log natural value, and its mathematical value is actually 2.718. This equation can be written as a over a minus x, that is equal to 2.718 raised to power kt. By inverting this equation, we have another form of this equation like a minus x over a. As we have inverted this left hand side value, definitely we have to invert the right hand side as well. Then we will have e raised to power minus kt, because we are inverting the sign of that side. By rearranging this equation is written as a minus x is equal to a into e raised to power minus kt, as a from the left hand side, which is in denominator of this side, will be shifted toward the right hand side as a coefficient. Similarly, a from the left hand side of this equation will be shifted toward the right hand side in negative sign, and we will have the remaining part is minus x is equal to minus a plus a into e raised to power minus kt. By multiplying this equation with the negative sign, we have x is equal to a minus a into e raised to power minus kt, and x is equal to a taken as a common will be the equation will be like that: x is equal to a into 1 minus e raised to power minus kt. And this one is another equation, which is equation 7, a linear equation where the intercept is 0 and x is equal to y and m is equal to a and x is equal to 1 minus e raised to power minus kt, or it may be the value of t, which is equal to minus multiplied by minus will be equal to a positive value. X axis at x axis we will have 1 minus e raised to power minus kt or t, while y axis we have the value of x, which is the concentration of our product, and slope it will be in positive sign, having the value of a in our equation 7, and intercept is 0, which is passing through the origin. By drawing this equation graphically, at x axis we have the value of time, at y axis, y coordinate, we have the value of x, which is the concentration of our product, and we will have such type of curve. And by drawing a tangent line on this graph, we will find the value of slope by drawing a right angle triangle, or we may have the value of theta angle, and it will represent the value of slope. While the slope also can be calculated by a trigonometric method, that is actually perpendicular over base, which is our value of a, also by tan theta value, and triangle right angle triangle slope finding value, we may have the value of initial concentration, while the intercept is 0 and line is passing through the origin.